All right, so this video is involving combinations, okay? I know there might be some permutations in here, but for the majority, this is a video kind of focusing on combinations, and we'll take a look at these scenarios and see, again, what characteristics of a combination are as opposed to a permutation. Looking specifically at letter K and letter A. Again, it's the same exact scenario, but look at the question and how it's phrased. So let's look at letter K first. 7 students are running for 2 positions on student council. In the voting, how many different first, second place finishes are possible? Okay, so the big clue here is that how many different first, second place finishes. Okay, so it wants a specific kind of finish, right? It wants to know first, second place, and that seems to be very where the order is important. And remember, if the order is important, that means we have a permutation to deal with. Okay, so for this problem, there are 7 students, so that means n is 7. And there's 2 positions, or again, first, second place, so that means I have 2 of the amount I want. So 7 permutation 2. Again, I could show you the formula, but at this point, hopefully you have a calculator that can do this for you. If you need to see the formula, I need to do it that way. Look at one of my previous videos. I outlined it there. So 7 permutation 2 gives me 42. So there are 42 different first, second place finishes that are possible for letter K. All right, for letter A, again, the same numbers, but look at the question. It says, how many different pairs of students could be elected? So it doesn't matter if they're first or second place. It just, if I just need to pick 2, who would I pick? So how many different pairs? So it doesn't even matter if it's first or second place. It just is different. Okay? So that would be a combination. So this is 7 combination. Let's get out of the highlighter mode. 7 combination 2. So 7 combination 2. I get 21. And as I described in the other video, it's the same exact numbers, but when you have a permutation as opposed to a combination, combinations, because the order is not important, means that we're going to have less arrangements to go from. But if the order is important for like permutation, that means we're going to have a lot of different unique arrangements. So that's why there's more in this particular case. Okay, let's take a look at letter F. Okay, so letter F is going to be a good one there, and then we'll also take a look at letter T, and then we'll talk about the other ones in class if you have questions. So, letter F. A student must answer any 4 of the 6 essay questions on a history test. How many different selections are possible? Okay, now, another thing that I always say about permutations is that usually you wouldn't want to repeat yourself, right? You wouldn't want to repeat the answers you've already done. However, okay, you don't have to do the questions in any order, right? So there's 6 essay questions, but I can start with question 6, then go back to question 3, then do number 2, then 1, right? I could pick whatever order I want for the questions. So that is a good example of a combination, okay? So I could rearrange the essay questions in whatever order I want. Order is not important. It's not like I have to do 1, 3, 4, 6. I have to go in a particular order. I could start with 6, go back to 2, jump back to 4, and then go all the way back to 1 if I wanted to. So, combination, there are 6 essay questions. I have to choose 4 of them. So 6 combination 4 produces an answer of 15. So there's 15 different ways I can pick which questions I want. Okay, and then letter T. How many different 6-player starting squads can be formed from a volleyball team of 11 players? So normally when we think of a team, okay, a team usually has a specific way that they go about it. Now, if it was in this volleyball scenario, if they asked how many different specific serving rotations can I make with 11 players, that's different. But it just says 6-player teams, 6-player squads, starting squads. So it's not saying they have to be in a particular position or a particular rotation. It's just saying how many different 6-player teams can I make of 11. So simply, that's a combination. Okay, I have 11 players on the team, and I need to pick 6 of them at a time. So 11 combination 6 gives me 462 different ways I could set up the volleyball team for that particular game. So this kind of gives you some insight there. I believe I covered the only permutation question on this portion here. All of these should be combination questions. But don't just take my word for it. You remember, you have to defend yourself, and I've given you reasons why in a couple of the videos as to why these would be combination questions, so make sure you're able to defend your response, whether or not it's permutation or combination.